Oh, well, hello and welcome. And just taking it further, and I was solving a few problems from RMM mock test as produced by the Sophie Fellowship. So here's the third problem. It's still about geometry. It says that in a convex quadrilateral, ABCD, the diagonals AC and BD meet at a point P, and we know that angle DAC is a right angle, and two angle ADB is equal to angle ACB. And if we have something, then prove that something is true. As always, that what we're thinking of here is that can first of all try to produce a nice diagram. And so it says that angle DAC is a right angle. So first of all, I'm going to make angle DAC. That's a right angle. DAC is a right angle. And where is B? Uh, well, since it's a convex quadrilateral, B would be something around here. We have been given that the diagonals BD and AC, they intersect at P, right? And then there are a few more things that 2 times angle ADB is equal to angle ACB and so on. So which means that 2 times angle ADB. So if this angle is theta, this angle must be 2 theta. Uh, okay. Firstly, let me tell you that it's not as if that I didn't wonder that is it going to be something like this, that with AB as center, if you draw a circle whose center is with AB as point on the circumference, if you draw a circle as center C, then does that mean that this point D will lie on the periphery, because this angle is half of this angle? And this is one of the properties of a circle, that the angle subtended at center is twice the angle at the circumference. But an immediate realization that we don't know anything about CA and CB, that they're equal, so we can't say, and therefore I didn't pursue this line of inquiry. Anyway, so what I'm going to do next? Well, I'm going to do simply, I'm going to chase angles and see that if you get something nice. And since we are being asked the ratio of two sides, AP by BP, where do you get ratio of two sides? Either you have to invoke similarity, or you have to invoke congruency, or you have to use sine rule. There are few ways by which you can get ratios, right? Okay, right. So let's chase angles. So this angle is theta. So this angle must be 90 degrees minus theta. This also must be 90 degree minus theta by virtue of being vertically opposite angle. Due to angle sum property, this angle must also be 90 degrees minus theta. And that immediately tells you that this side and this side are equal. Right, now I come to the next information, that angle DBC. Now that I know what angle DBC is, which is 90 degrees minus theta, plus 2 angle ADC is 180 degrees. And that tells you that 2 times angle ADC is equal to 90 degrees plus theta. So angle ADC is equal to 45 degrees plus theta by 2. Right. And since this total angle ADC is 45 degrees plus theta by 2, so this angle here must be 45 degrees minus theta by 2, so that these two angles can add up to 90 degrees. Right. And now you can see that, well, this is 45 degrees minus theta by 2, this is 2 theta, this is 90 degrees minus theta. And using the angle sum property, this angle plus this angle, this must be 180 degrees, right? So this angle is 90 degrees minus theta. This is 2 theta, so they add up to 90 degree plus theta. So this angle add up to 135 degrees plus theta by 2. So for these three to sum to 180 degree, this must be 45 degrees minus theta by 2. This angle must be 45 degrees minus theta by 2. And that tells you that this side are equal, right? Because these angles are the same, right? Okay, and now what is it that we have to find? Actually, we have to find, well, AP and BP. So have a look at triangle ADAP. You can see that AP is DP times cos of 90 degree minus theta. Cos of 90 degrees minus theta is sine theta. So which is DP is as good as CP, and CP is like whatever CP is. We'll come to that. Now have a look at this is equal to CP sine theta, right? And now what I'm going to do is that I'm going to use sine rule. Where I'm going to use sine rule? I'm going to use sine rule in triangle BPC because there is the side BP involved, right? So what do you see? What do you see? So what you see is that BP upon sine 2 theta, BP upon sine 2 theta is equal to, what's that equal to? Well, it's equal to, well, CP upon sine 90 degrees minus theta. Now this would mean that BP upon 2 sine theta cos theta, CP. CP is, have a look at this, CP is nothing but AP upon sine theta and into cos theta. And that tells you that BP is equal to AP, and we are done.